Okay, hello and welcome to today's lecture. So we're almost done with chapter 3. There are some concepts that later on I'm going to talk about. Those concepts are coming from chapter 3, but we just went over the introduction about probability yesterday. Today we're going to actually start chapter 4. Before starting chapter 4, before talking about the objectives for chapter 4, let's take a look at the highlights for week 3. First of all, we have our group quiz 2 on Thursday. We have extra credit due on Sunday. Please log into your Canvas. Please go to week 3 module. Take a look at your extra credit for chapter 3. We also have a discussion about addressing test anxiety. I would like you to take that discussion, respond to 2 of your classmates. It's very helpful, it's very useful, informative. So these are the highlights for our week 3, the assignments that you need to submit for me. 2 of them are due on Sunday, and we have a quiz 2, which is on Thursday. Very well. So we are on chapter 4, 4.1. You can find all notes posted on Canvas related to chapter 4. You can find all of them in week 3 module. Very well. So what are the objectives of chapter 4? What are we going to learn today? So the objectives, we're going to learn about different variables, discrete and continuous variables. We are also going to introduce a binomial experiment. Binomial experiment. So 2 objectives for you. Note that we're going to use our calculator as well. Very well. So what we learned so far? Recall that in chapter 3, we start talking about probability of an event, and we learned that we have a classical way of finding the probability of an event. So we say that, hey, we have a sample space like S. We can define some, we can take some subsets of that sample space and define events like E, F, and so on, and we can find the probability of that event, which is equal to a fraction. On the numerator of the fraction, we have the size or cardinality of that event, N of E. On the denominator, you have the cardinality or size of your sample space. Very well. Today, we're going to actually define random variables, and instead of using events, we're going to use our random variables. So, what is a random variable? We are on page 1 of 4.1. A random variable, which is denoted by X, so random variable, a random variable, which is denoted by X, represents a numerical value or numbers. Numerical value. Very well. So, when it comes comes to random variable, we have two different types of random variable. It can be countable or discrete. So a random variable like x, it can be either countable, we can count it, countable, or discrete, or it can be uncountable or continuous. Continuous. Well, give us an example. An example of a discrete random variable is the number of students sitting in Math 10 class. I can actually count the number of those students sitting in my class. For example, the number of students in Math 10 class. I can count them. 1 student, 2 students, 3 students, 4 students, 5 students, and so on. How about a continuous random variable? A continuous random variable is like a variable that takes on values between 2 other numbers or a range of values. You cannot count them. You have those numbers in decimal form. Like what? Like heights, like weights, like volume, like area. Example, area, volume, heights, weights, and so on. So again, countable or discrete, I can count them. Continuous, you cannot actually count them. It's usually represented by decimal numbers. So let me write this for you here. Decimal numbers. Well, let us move on to more examples. There. We are still on page 1 of the note. Very good. Here you have an example. So question says which one is discrete, which one is continuous. Which one is continuous? Very good. The first one says let variable x, remember that you're working with random variables, random variable x represents the number of 500 companies. That lost money last year. And the second one says, hey, let x represent the volume of gasoline. Let x represents the volume of gasoline in 21 gallon tank. 21 gallon tank. Which one is countable? Which one is discrete? You can actually count. Which one is continuous? Okay, what do you think, guys? The first one. Okay, the first one is?
Discrete.
Discrete, very good, very good. One is discrete, thank you, Gilbert. Well, you're waiting for the rest of the class. Very good, 2 is continuous, okay. 2 is continuous, thank you, Max. Very good. The first one is countable. The first one is countable. Very good. The first one is discrete. Excellent. Very well. Very well. Very well. Yes, Elaine. Thank you, Marvin. Thank you, Darren. Thank you, Olivia. Very well. Excellent, guys. So, since we can count the numbers of companies that lost money, since we can actually count the number of those companies, it is discrete. Discrete. What about the second one? Can we count? What is it? Is it 1? Is it 2? What is it? It's the volume. Volume is continuous. Since we cannot count the volume, it is continuous. Very well. So we introduced discrete and continuous variable. Now we're going to talk about their probability distribution. Our focus is on probability distribution for a discrete random variable. So we're moving on to page 2. So now that we introduced a random variable, we want to talk about the probability of that variable. We want to calculate the probability of that random variable. So we first represent this by P of X, the probability of a random variable is denoted by P of variable X. Remember last time we had P of an event. Now that we introduced a variable, instead of using that event, we're going to use P of X, X itself. Very well. Now I expect you to ask, since you introduced 2 different variables, are we going to work with 2 different probabilities? The answer is yes. In chapter 4, we just focus on probability for a discrete random variable. Probability of a discrete random variable. And in chapter 4, in chapter 5, we're going to talk about probability of a continuous random variable. Continuous random variable. Very well. So how do we construct a probability distribution function? So let X be a discrete random variable. P of X is the probability of that random variable X. It has some properties. First of all, the probability of random variable X is a number in between 0, 1 inclusive. Second of all, remember that if X is a random variable, it means that it is countable. It takes on countable values. So if you find the probability for each of those counts and add them all together, it must be equal to 1, 100%. So you write down the sum of all probabilities must be 1, 100% or 1. Mathematically, we write it this way. The sum, sigma, the sum of all of those probabilities for different values of X is equal to 1. Okay, let us take a look at this example in our note. Constructing and graphing a discrete probability distribution. Very well, an industrial psychologist administered a personality inventory test for passive-aggressive traits for 150 employees. Each individual was given a score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 indicated neither trait. The results are shown at the left. Question says, construct the probability distribution for the random variable X, then graph the distribution using a histogram. Very well. So let us write down the information about this example here. So first of all, note that your X is representing scores. These scores can be 1 or 2 or 3 or 4 or 5. So X can be 1 or X can be 2 or X can be score 3 or X can be score 4 or X can be score 5. First of all, is it discrete? Is it countable? How many counts do we have? We have 1, 2, 3, 4, 5 counts. So this is a discrete random variable. This is a discrete random variable. Well, let us write down the information that we have. On the left-hand side of the table, we're going to have all the scores. And on the right-hand side, we're going to have the frequency. How many people got score 1? How many people got score 2? How many got score 3? How many got score 4? And how many got 5? So 1 frequency is 24. So number 1 is repeated 24 times in your collection. 2, score 2, 33. It means that 33 people got score 2, score 3. You have 42 people, score 4. You have 30 of them, and 5, score 5. You have 21 people. How many people in total? What's the sum of the frequencies? It is equal to 100, 150. 150. Okay, now answer this. What is the probability of a person, you randomly select a person, and that person got score 1? So what's the probability that x is equal to 1? What is the probability that x is equal to 2? What is the probability that x is equal to 3? You randomly select a person. What is the probability that score of that person is equal to 3? What is the probability that the score is 4? What is the probability that you randomly select a person and that person had score 5? P of x equals to 5. Remember that. When we introduce the probability, we say that, hey, we need actual frequency or the count of all outcomes in our event. This is your event. Event is having score equals to 1. What's the size of that event? 24. So 24 goes on the numerator. What goes on the denominator? The size of your sample space. How many people were surveyed? 150 of them. The probability that x is equal to 2, there we go. The event is, the score is 2. How many people got score 2? 33 of them. So the size of the event is 33 over the size of the sample space. This is the size of the sample space. 150. What is the probability that x is equal to 3? What is the probability that you randomly select a person and that person got score equals to 3? 42 divided by 150. What is the probability that score is 4? What is the probability you randomly select a person and that person has score 4? 30 divided by 150. And what's the probability you randomly select a person and that person got score 5? 21 divided by 150. Note that each of these fractions must be a number between 0 and 1. It must be a small number. So let us do the division for each of them. What is 24 over 150?
0.16.
0.16, very good. So it means that you have 16%. 0.16, 16%, of course, it's a number between 0 and 1. What's the division between 33 and 150?
0.22.
22%. Excellent. Don't forget to mention percent. Excellent. Very well. You have a small number. If you say just 22, 22 is not in between these two numbers, means that it's wrong. So don't forget to write percentage or write it as decimal, 0.16 or 0.22. What is 42 divided by 150?
0.28
or 28%. Very good. Thank you very much. What is the probability that the score is 4?
20%.
20%? Very
Yes.
good. Thank you very much. And finally,
14%.
14%.
thank you very much. I love the participation in this class. Excellent. Excellent. Very good. These are the probabilities that we actually found for this discrete random variable. Discrete random variable. Okay. Now I expect you to ask, what should I do with these numbers? How can I visualize them? Well, they're going to use a histogram to visualize this probability distribution. Very well. So let us form out histogram. What goes on the horizontal axis? On your horizontal axis, you're going to list all of the x values. So your histogram. Here, you have all x values. And on vertical axis, you're going to use these percentages or decimals. P of x. Okay, let's try to scale this. We're going to have a nice histogram. We know that our x ranges between 1 to 5. So x can be 1, x can be 2, x can be 3, it can be 4, it can be 5. So we're going to start here. We have 1, 2, 3, 4, 5, 5 counts, discrete random variable, and the maximum percentage that we have is actually 28%. So I'm going to scale this guy to 0.30 or 30%. So I'm going to have 0.10, 0.20. Okay. My very first variable is 1. The probability that score is 1 is actually 16%. So my first bar is going to stop at 16%. The probability for x equals to 2 is 22%. So my next bar is going to stop at 22%. Very well. What if x is 3? X is 3, so I have 28%. My third bar is going to stop near 30. So let me just write this out here. Overlapping here, 28%, and this is my third bar. Okay, if x is equal to 4, I have 20%. 20%, very well. 20% matches here. Let's go a little bit further down. 20%. And finally, 5, when x is equal to 5, you have 14% chance. 14%, which is roughly here. 14%. So now suppose somebody gives you a table and they say, hey, this is the probability distribution that I found for my variable. Well, you're the statistician. Is this a correct probability distribution? Can you actually say that that's a probability distribution? Let's take a look at this example. On page 3, one of your friends collected a data. Your friend friend actually came up with this table. So this is on page 3. Your friend collected data and there is your friend's probability distribution. This is the table that your friend gave you. These are the x values, and these are the probabilities that your friend actually calculated. So here on the left-hand side, 0. The probability that she or he found is 0.260. This is the probability. Almost 27% chance that x is equal to 0. X is equal to 1. The chance is, the probability is 0.432. X is equal to 2, and the probability of x being 2 is 0.288. And finally, for x equals to 3, your friend says the probability is 0.064. Okay, what do you think about this table? This table represents a probability distribution or not? Is this table actually represents a probability distribution? How do you check that? You have some x values, you have discrete random variable, and this is the probability that they came up with. Remember that. Recall that. When we define a probability distribution, we mention 2 conditions for any probability of random variable x. If x is discrete, it must satisfy 2 conditions. The first condition is p of x for each of x values must be between 0 and 1. And second one, if you add them all together, the sum must add up to 1. And the sum of all probabilities must be 1. Okay. So let us check each of these one by one. P of x equals to 1. P of x equals to 1. Let's start with 0. 0 is equal to 0.216. Is this a number between 0 and 1? Is this small enough? Is this between 0 and 1? Of course. This is a number between 0 and 1. We don't have any problem with the first one. What's the probability that x is equal to 1? What is the chance that x is actually 1? Your friend calculated that as 0.432. Is this a number between 0 and 1? Of course. It's not negative, it's not greater than 1, so we're good. We're good with the second probability. How about the third one? 0.288. P of x equals to 2. The probability that you randomly select a just value and that value is equal to 2 is 0.288. Is this a number between 0 and 1? Of course. And finally, the probability of x being 3 is equal to 0.064, which is a small number in between 0 and 1. So we don't have any problem here as well. We're good. So the first condition is met. How about the second condition? What if I add all of these numbers together? What I get? What's the sum of this probability, this probability, this probability? If I add them all together, what is the sum of 0.216 plus 0.432 plus 0.288 plus 0.064? Is this equal to 1? What
Yes.
is it? Yes, very good. Very good. Excellent. This is equal to 1. So the second condition is also met, and you congratulate your friend and say, hey, the thing that you actually calculated represents a probability distribution function. Very well. Let us do a quick checkpoint. Checkpoint 1, a company tracks the number of sales new employees make each day during a 100-day probationary period. The results for one new employee are shown below. Construct and graph a probability distribution. So first, we have to find the probability of each outcome. Then we have to organize the probabilities and then use a histogram to graph it. As you can see, your left column is representing X values. X can be 0, no cell. X can be 1, 1 cell. X can be 2, 2 cells, 3 cells, 4 cells, 5 cells, 6 cells, and 7 cells. The number of days. So 16 days that new employee sold nothing. 19 days that employee sold one item. For 15 days, X was equal to 2. So for 21 days, it was 3 sales per day. In 9 days, it was 4 sales per day, 5 sales per day, repeated 10 times, 6 sales per day is repeated for 8 days, and only 2 days, that person sold 7 items each day. Okay, you have the frequency for each of X values. You need to construct the probability for each of X values. Let me write down the question here for you, the checkpoint. We have the number of cells X, 0, 1, 2, 3, 4, 5, 6, 7, and we have the frequency. The frequency is 16, 19, 15 days, 21 days, 9 days, 10 days, 8 days, and 2 days. So this is your frequency. And here you have your X values. As you can see, your X is countable, so X is discrete. Okay, to find the probability for each of these X values, we have to do a little bit of algebra. So P of X. P of X equal to 0, no cell, is 16 divided by P of X equals to 1 is 19 divided by P of X equals to 2 The frequency is 15 divided by P of x equals to 3 is 21 divided by P of x equals to 4 is 9 divided by P of x equals to 5 is 10 divided by P of x equals to 6 is 8 divided by, and P of x equals to 7 is 2 divided by. What is the denominator?
100.
100? Very good. 100 days. Very good. So you have to repeat 100 down here. Very good. 100 and 100. So the frequency of your x is 16. The frequency of no sale is 16 days. For 16 days, that person didn't sell anything. No sale at all. 16 divided by 100, 16%. So you can say that, okay, this is 0.16 or 16%. 0.19, 19% is the chance. 0.15, 15% is the chance that that person sold 2 items. 21%, 0.21, 21%, 9%, 10%, and 8%, so 0.08, 8%, and just 2%, 0.02, 2%. Okay, how do you graph this? On the horizontal axis, you have your x values, 0, 1, 2, 3, 4, 5, 6, 7. And on the vertical axis, the maximum percentage is 19. So let us scale it to 20, 0.20. This is your P of x. This is your x. So 0, 1, 2, 3, 4, 5, 6, and 7. So here you have 10%. So the first bar is for x equal to 0. X equal to 0, the probability of no sale is 16%. So our bar is going to stop at 16%. So this is your very first bar. 16%. The probability of one sale is 19%. Okay, 19%. So let me write 16% here. 19%. This is your second bar. 19%. The probability that that person sold 2 items is actually 15%. 15%. The probability of x equals to 3 is 21%. Okay, 21%. So we can scale that up here. This is 15%, 21%. The probability that x is equal to 4 is just 9%. So we're going to stop the bar here. 9%. X equals to 5, 10%. 10%, so a little bit up here. 6 items, 8%. 8%. And finally, 7 items, 2%, which is just right here. So now I expect you to ask, how do I visualize these data? Okay, 0 has frequency 16. What's the meaning of that? It means that 0 is repeated 16 times. $14, $15, and 16. 0 is repeated 16 times. 1 is repeated 19 times because it is 19. So 1, and 19. 2 is repeated 15 times. 2. And you can actually just list the rest of the numbers that you have in your collection. So this is the data they actually collected. They used 1, 0 as the representative for your X, and the frequency is 60. They used 1 as the representative of all those ones, and 19 is the frequency. And they continued this process. So as you can see, we are using a frequency table, the exact first thing that you learn to visualize the data, to write the data in a nice, compact form. Now I expect you to ask, what is the mean of the data? What is the standard deviation of the data? How can I use the probability P of X to actually calculate the mean and standard deviation? So I'm not going to erase this. I'm going to use this example to actually show you how to use your data and also probability of variable X to find the mean and standard deviation. Very well. So let me erase this here, the graph. Okay, I'm going to just erase these percentages as well. It's easier for me to work with decimals. I asked you to find the mean of the collection. How do you find the mean of the collection? What do you do? To find the mean, you have to add all of these numbers together, 0 plus 0 plus 0, or 0 times 16, plus 1 times 19, 1 is repeated 19 times, 2 is repeated 15 times, plus 3 is repeated 21 times, plus 4 is repeated 9 times, plus 5 is repeated 10 times, plus 6 is repeated 8 times, plus 7 is repeated 2 times, so let me write it here. 7 is repeated 2 times. So we're going to add all of the data that we have and then divide it by 100. Okay, do the calculation for me and to find the mean here. What would be the mean of your collection? $12.5, 2.6. Okay, we get different numbers. Very well. One student has 12.5, another student has 2.6. Very well, calculate it for me. Remember that it must be a number between these, between 0 to 7. 2.6, okay, okay. Very well, the second person, okay. Next person, okay. Thank you, Adlan. Thank you, Fabiana. Thank you, Mingzhan. Thank you, excellent. Rebecca, excellent. So the mean is equal to 2.6. Now,
To find the mean.
this is your mean, 2.6.
Oh, okay, I see.
2.6. 2.6 is a number between these. Of course, that makes sense. 2.6 is the average number of sales that person did during 100 days. 2.6. 2.6. The balancing point, 2.6. 2.6. Okay. Now, how do we use these information to find mean? To find mean by using the probability to find the mean by using px, we have to create a new column. This new column is actually the product of x and p of x. So here you just multiply x by p of x and you add all of them together. So x is 0, 0 times 16%. 1 times 19%. Here you have 2 times 15%. Here you have 3 times 21%. Here you have 4 times 9%. Here you have 5 times 10%. Here you have 6 times 8%. And finally, you have 7 times 2%. What are these numbers? And what would be the sum? The first value is 0. The second value is 19%. This guy is 30%. This guy is 63%. This guy is 0, 36%. This guy is 50%. This guy is 42%. And this guy is 0.14%. What's the sum of these numbers? What would be the sum here? If you add all of these numbers, what do you get? What would be your calculation here?
260.
260? You have a
2.6.
2.6. You get the exact mean, which is 2.6. 2.6. So, if you have the actual data, you can find the mean. If you don't have the frequency, suppose the frequency is missing, you only have your x and p of x. To find the mean, you multiply each x by p of x, add them all together to get the mean. So the formula for the mean is the sum of x times p of x. Record this. Thank you, Fabiana. Guys, this is 48, not 42. Please correct that. Well, now I expect you to ask, you found the mean for us. How can we use the probability px to find the standard deviation? There you go. So let's forget about these data here and write down the formula for standard deviation. Of course, we need a new column. After finding the mean, we're going to use the mean. So we found the mean. Our mean is equal to 2.6. Mean is 2.6. So let me write the mean here. Mean is equal to 2.6. Now to find the standard deviation, you have to create a new column. In this new column, you have to find x minus mean, square it, and multiply by p of x. Then you find the square root of the sum here. Square root of the sum. There you go. Okay. We have work to do. The first x is 0. So I have 0 minus the mean, which is 2.6 raised to 2 times px. 0.60. The second x is 1. So now I have 1 minus 2.6 squared times its p, which is 0.90. The third x is 2. So I have 2 minus 2.6 squared times its probability, which is 0.50. My next x is 3. So I have 3 minus 2.6 squared times 0.21. My next x is 4. So I have 4 minus 2.6 squared times 0.09. My next x is equal to 5. I have 5 minus 2.6 squared times probability, which is 10%, 0.10. And finally, I have 6 minus 2.6 squared times its probability, which is 0.08. And finally, my last x is equal to 7. 7 minus 2.6 squared times its probability, which is 0.02. After finding these numbers, you have to add them all together, take square root to have your standard deviation. Okay, guys, take your time, calculate this for me. So what is your first number?
1.08.
1.08. The second number?
0.48. 49.
49, okay. Next number?
0.05.
0.05. Very well. The next one?
0.03.
0.03. The next number?
0.18.
0.18. We have 3 more numbers.
0.6.
0.6. And then 2 more.
0.92.
Finally,
0.39.
now you're going to add all of these together, the sum, then take square root to get your standard deviation. So please find the sum first for me. So if you add all of these together, the sum is equal to
3.74.
3.74. And what's the square root of 3.74?
1.93.
1.93. Standard deviation.
2.
So it's close to, if you round it up, you get 2. So it says on average, it's just select a random X, the number of cells. That number of cells is different from the mean 2.6 by almost 2 cells. Almost 2 cells.
And I have a question. Why we use